When you're working with electronics like Arduino, purchasing a physical part that works perfectly isn't always the only solution to a problem you might come across. Some problems can be solved entirely with code. So let's look at an example from an early lab in Intro to Instrumentation. When you press a button, the open circuit inside becomes closed, right? So that the current can flow through it. But the circuit doesn't always close perfectly cleanly. Sometimes it can bounce, which is going to be causing like extra on-off inputs. This can be an issue if we're making a button counter, for example. So if we want to debounce the button, we could add some additional hardware. I looked online and you can use an SR flip-flop circuit. That solves the problem perfectly. But if you're already connecting the circuit to an Arduino controller, we can save some space and some money by coding a solution instead. Let's take a look at the circuit we're working with here. So we have a button up here. That's what we're pressing. The green light is going to light up whenever we press the button to tick up the counter. The red light is going to turn on whenever a signal is rejected, right? Whenever the code detects it as a bounce instead of an actual button press. You can see nothing in the circuit itself actually prevents bouncing. We're going to code it in, and then the red light is what will show that it's working. Now let's look at what the code does. Up here, we're just doing like setting up all the variables, turning the machine on. Notably, right here it says whenever you press the button, it's going to trigger an interrupt. Before we look at the loop function, let's go all the way down here to look at the button interrupt function. This is going to basically activate whenever the interrupt triggers, so whenever the button is pressed, or whenever a bounce happens. So whenever one of those two things happen, we're going to set count just increased to true. Now back in the loop, it's just going to continuously run this if statement, right? And it's going to check if count just increased is true. If it is, it's going to first set it to false so it can prepare for the next loop, and then it will tick up the counter and turn on the green light. But this second line here basically says if the count just increased, but it hasn't been 100 milliseconds since the last time that it was triggered, then the computer is going to block the counter and it will turn on the red light instead. 100 milliseconds is faster than a person can reasonably press the button, which means that it's only going to be blocking the bounces and not our actual button presses. And there you have it. This simple part of our lab, it helps us keep our minds open to all the possibilities we have when we're working with these circuits, right? Any problem can be solved in a plethora of different ways, whether it's hardware or if it's software. We keep this in mind as we move on to more and more complicated labs in the future. Thank you for watching.